Alaikum. Today we are going to discuss this paper 4. It's alternative to practical 507042 and May June 2021. It's a paper for 1 hour. Let's start its first question. Yes. Hydrated magnesium sulfate at the formula of MgSO4.X-H2O. So we have X, it means we have to find the water crystallization. When hydrated magnesium sulfate is heated, it loses the water of crystallization to form anhydrous magnesium sulfate. So this becomes anhydrous, this is the hydrated, okay? By the loss of water, it becomes anhydrous. So a student does an experiment to find the value of X in the MgSO4. The student records the mass of the crucible, means the mass of that type of the apparatus which contains, in which we place it, okay? Add the hydrated magnesium sulfate to the crucible. Hydrated is added, okay, this one is added. I record the mass again, then it's again mass is recorded, okay. Difference of both of these, mass of crucible, and then after adding this, so difference of this these two shows the mass of magnesium sulfate hydrated, okay. Heat the crucible strongly, then it is heated. Allow the crucible and content to cool, and then record the mass again. Then it is allowed to cool, and then we can find its mass again. But this process is repeated again and again. It means 3 to 4 times we heat it, then we cool it, and then we find its mass, so that all the water of crystallization which it contains will be evaporated, okay. Use the result to calculate the initial mass of the MgSO4 and the final mass of MgSO4. So we knew the mass of the MgSO4 hydrated one, and then at the end we can find the mass of the MgSO4, that is the anhydrous, okay. So suggest why the crucible is heated instead of glass beaker. Because it is resistant to heat, okay. Resistant to heat, doesn't get broken by the excessive heat. Glass beaker cannot resist heat, okay, so it will get broken. And secondly, it gives entire heat to the substance, okay. Suggest why 3 to 4 times are repeated, okay, until the same mass is recorded twice, until the mass becomes constant, okay. Once it has become constant, then you heat it again, and then again you find the same mass. It means all the water which it had, water of crystallization, has been evaporated. To evaporate, why it is why 3 to 4 times are repeated until the same as, to evaporate all the water of crystallization, all the water, okay. So we have this one, initial mass of MgSO4. Several students do the same experiment with different initial masses of MgSO4. Means this one experiment which we have just now read, okay. This experiment is done by the students, and they have initial mass of magnesium sulfate, hydrated one, this one, and then when they do 3 to 4 times, and they get constant mass by twice, then they leave it, okay. It means all the water has been lost. So in fact, this is the difference of 0.27, okay. This is the water which was lost, okay. And here is the difference of 1.04, okay. So okay, this is very carefully we have to draw the graph, okay. Complete the table, done. On the grid, plot the final mass of MgSO4 against the mass of H2O lost, okay. This is the final mass of the MgSO4, Okay, final mass, this one. Okay, this is on the y-axis, and against the mass of water lost, so this is on the x-axis. Okay, so 0.25 final mass of the magnesium sulfate. Let me minimize it. You would have scale. Okay, by using the scale you can make this graph with great accuracy. So final mass of MgSO4 0.25, so 3 and it becomes 0.25 almost here, and then next is 0.27, like this. Okay, here. Okay, so next 0.48 and then 0.50, so 0.48. Okay, and the next is 0.50, 4, 6, 8, 10. Means each is showing 2. Here is. Okay, something like this. Because I am minimized, I have to see this one as well. Okay, in this way you will make 0.83 and 0.67. 0.83, 0.83, 8, 2 and 3. This one, okay, and then next is 0.67, so 6, 7, 1, 2, 4, 6. Here something like here, okay, like this. The next is 1.00, that's okay, this is the main line, and the next is here is 1.04. Mass of MgSO4, final mass of MgSO4. So this is this one, okay, and then what we get? 1.04. Like this, okay. So in this way you will make, okay, and 1.23, here is 1.23, and then 1.30. So 30 means 1.23, 1.23. So this is not 0.2, 23 means 1.2, and this is 2.23, something like this. Okay, 1.02 it becomes. Sorry, 1.2, 1.4, so 1.23, and the next is 1.30, almost here, okay. So one 1.46 and 1.53, 1.46 and 1.53, like here. So almost you will get the straight line, okay, almost this had to be here, but this will be an anomalous point. Let me tell you. This will be a straight line and this will be the anomalous point, okay. The reason is because it doesn't come on the straight line. When you will draw this, okay, then you will get to know that this is the anomalous point, okay. All others are in the same line, they will give the same line. So suggest why for the anomalous result, because the final its mass is greater than other masses, so it means it has not lost the water, okay, totally. If it would have lost all the water crystallization, its mass would have decreased and it would never be anomalous, okay. So we can say, so just the reason for the draw the circle. For this you will get 1 mark, okay. And the reason, because all water has not been lost. Okay, draw the straight line of the best fit. So this will be the straight line. Hopefully you will have, when you will have this fully graph and you will draw the straight line, it shouldn't come here. I think this is the fifth one value, 1.23. Okay, yeah, this is 1.2, sorry, it doesn't come here. 1.23, this is 1.2, 2.2, this it comes here, okay, 2, 3, this is the one. So this is the line which fits the best, okay. And 1.46, 1.4, 2, 4 and 6 here. So it is possible when you will have scale. Straight line, we have drawn the straight line. In another experiment, the final mass of the MgSO4 is 1.20 gram. Use the graph to determine the mass of H2O last. So 1.20. Okay. So let me tell you 1.20. If we have 1.20, the final mass MgSO4. Okay. At this point, what we get? 1.2 to 1.24 and 1.26. Yes, it's 1.26. Water last. Okay, because this is another experiment in which this is the point 1.20. Okay, 1.20. So what is the mass lost? So have a look. It should become 1.26. Okay, like this, it will become 1.26. Calculate the number of moles of water and your answer to 1. (1.26) divided by 18, it becomes 0.07. I think we can use the calculator. If we have, sorry, we need to have calculator. Yes, 1.26 divided by 18, the mass of 0.07. It's okay. Okay, 1.20 mass of MgSO4 and the mass of contains 0.1 mole. This is the 0.1 mole. So X will be equal to, let's see, if we have MgSO4, and then we have H2O. So its moles are 0.01 and its moles are 0.07. We divide it by the least moles, 0.01, 0.07. So it is, sorry, this is also 0.01. The least one is, okay. So it becomes 7 times and it becomes 1 time. So here X means the 7 H2O. Question number 2. Aqueous sodium hydroxide, the solution contains 2 different cations and 1 anion. Complete the table. There are 2 different cations, okay. So name any gas formed and describe the test used to identify this gas. So we don't have to answer over here, okay. To the same boiling tube, continue adding the aqueous sodium hydroxide until the excess. Keep the content of the boiling tube for the test 2. Okay, you have to keep the solution for test 2. A green precipitate is formed, it dissolves to form the green solution. So when the green solution is dissolved, so it is the chromium. It is chromium plus 2. Okay, and a white precipitate remains. This is calcium. Okay, when the green precipitates do not dissolve, then we say this is the iron Fe+2. When they get dissolved, then it is the chromium, and this is the calcium plus 2. What is test for anion? We need to have solution. Okay, what we do, we add NaOH, we add aluminium, plus we heat it. Okay, so upon heating, a gas is released. Okay, which converts or which turns red litmus paper blue, means that gas is the ammonia. So anion is identified. This anion NO3 nitrate ions. This is test for nitrate. Ammonium sulfite is a water soluble compound. This is sulfite. You can see SO3. So aqueous ammonium sulfide is added slowly oxidized by oxygen in the air. When it is oxidized, so it means it becomes sulfate. Okay, this means ammonium sulfide will also contain some sulfate ions. It doesn't mean that all has been oxidized. Now it contains SO3 minus 2. It contains SO4 minus 2. Okay, and ammonium is already there, NH4 plus. Discuss a series of tests and observation to show the presence of ammonium ions, sulfide ions and the sulfate ions. So for the ammonium, what will you do? Let me tell you for ammonium. Okay, NH4. You will write. You add NaOH plus you heat it. So upon heating, a gas is released. This is the test. Okay, this is the test, and this is the observation. What will you observe? Gas is released, that is ammonia, in fact, which turns the red litmus paper blue. Okay, this is test for ammonium. Next is test for the sulfide ions. Sulfide ions. SO3 minus 2. You add dilute ICl. Okay, so sulfur dioxide is produced. Okay, a gas is released, and that gas is the sulfide. Okay, that gas is the sulfur dioxide, which is oxidized by the KMnO4 litmus paper, which KMnO4 litmus paper turns colorless. Okay, so it means this has been oxidized, but this gas is produced. When this gas is produced, it means sulfur dioxide. But in case of sulfate, you add you take sulfate and you take all of these in different beakers. Okay, the same solution you take. So when you are using for this ammonium, so you will get this ammonia gas. Okay, so when you are testing for sulfide, you will get sulfur dioxide. When you are doing for sulfate, then you add barium nitrate. Okay, so what will you observe? White precipitate you will find. Okay, so you know why white precipitate is found? Because of the barium sulfate, which is insoluble. So in this way, sulfate ion will be confirmed. Okay, a titration method can be used to make the soluble salts. It's okay, you can have a look. This is the titration method. Okay, sodium chloride he has to prepare. The step 1, student use the measuring cylinder to add 25. He uses the measuring cylinder. Okay, sodium hydroxide to add NaOH. Okay, so state how the accuracy of experiment could be improved in step 1. Instead of using the measuring cylinder, he could have used which thing? Pipette. Okay, so pipette is used to measure the exact quantity of the liquid. Okay, and it has more accuracy. Describe what student does in step 2 of the method. Include the name of the apparatus A and B. What student does in 2? Okay, A and B. A is the, okay, student adds or fills burette, which is the A. by acid, okay, ICL, because he has to use ICL to make the NaCl, okay, by acid contained in a beaker till its scale 0 with the help of funnel. Okay, by using the funnel, it fills the acid. This is the acid ICL. Okay, and the burette. This is the burette. Okay, till the scale 0 up to 0. Okay, identify what is added to the flask in step 3. After adding acid in this one, okay, and this indicator is added. Okay, before proceeding the titration process, indicator is added. And step 4, the student adds solution B to the aqueous sodium hydroxide to the conical flask. The student records the volume of the solution B added. State how the student knows when the endpoint is reached. So indicators, the color of indicator is changed. Okay. Indicator changes. So when the color of indicator changes, so it means this is the end point. Okay. So why we add indicator? Actually, it tells the end point. Okay. The rest of the method involves the adding the recorded volume of this of the solution to another 24 or 25 of the sodium. The rest of the method involves the adding the recorded volume of the solution. B means adding more. Okay, substance added in step 3 of the first iteration is not added. The substance added in step 3 of the first iteration is not added. State why this substance is not added. Means further when the titration is finished, so further indicator or something else means any other solution is not added, because it contaminates the contaminates the products. Means once we have added B into 25 cm³ of the aqueous sodium hydroxide, B is actually HCl. Okay, titration is ended. So adding further B means this solution can cause the contamination of the products. Means the products will get impaired. Okay, describe contamination means to get impaired. Describe how the student obtains pure crystal of the sodium chloride from the solution in the conical flask. So by heating, okay, to make saturated solution. So when the saturated solution is made, okay, then it is cooled, okay, in a china dish. It is cooled, okay, and then those crystals crystal formed are dried in the filter folds. Okay, filter paper folds. Crystals formed are dried in filter paper folds. So we heat that solution, the excess water is eliminated and this solution becomes saturated, or it becomes a dense, it becomes a viscous. So then it is saturated solution, but when it is cooled in the china dish, okay, then crystals are appeared which are further dried by folding in the filter papers. Okay. Oxidized sample of ethanol. Ethanol is oxidized. Okay. So some apparatus shown. Name the three pieces of the apparatus. P. This is the condenser. You would have seen the water ends here and is released from here. Water is going to enter and going to be removed over here, and here something which evaporates or vapors, those condense back, okay, become liquid. So Q is the round bottom flask. Round bottom flask. Why is the conical flask? Why is the which thing it is? It's funnel. Sorry. The student transfer 25 cm of ethanol into this. Okay, here ethanol C2H5OH ethanol 25 cm is added in this. Okay, as oxidizing agent because he wants to oxidize it. Assemble the apparatus as shown. So in this way apparatus is assembled. So name the apparatus Q gently until heat the apparatus Q gently until the oxidizing agent has changed color. When the color of oxidizing agent is changed, so it means it has oxidized. Okay. Name the suitable piece of the apparatus to measure the 25 cm of the ethanol. So pipette. Okay. Name the oxidizing agent. So oxidizing agent is acidified KMnO4. Okay. Potassium manganate. State a change color that could be seen on oxidizing agent. So purple to colorless. It's actually color is purple. Okay, KMnO4 color. The color of KMnO4 is purple and becomes purple to colorless. So it means the substance has been oxidized. Suggest the reason for placing apparatus P vertically. Which one? This is the P. Why we place it vertically? Actually, we know that this ethanol, when this contains oxidizing agent, when it is heated, so its vapors may be escaped from here. So when we are using condenser vertically over here, so those vapors will not be removed, will condense back, okay, in the same solution. So to condense back C2H5 vapors of ethanol, vapors of ethanol. After all the oxidizing agent reacts, apparatus Q contains a mixture of ethanol, water and product of oxidation. Name the product of oxidation. We know when the ethanol is oxidized, so it becomes ethanoic acid. Okay, you have studied in process of fermentation and while preparing ethanoic acid, that ethanol is oxidized to ethanoic acid. Okay. Then the process used to separate the three liquids in apparatus Q. So fractional distillation. Know that fractional distillation is used to separate the different miscible liquids, means which are soluble into each other. So those are separated by fractional distillation. State why this process is suitable. You should refer to the physical property of the liquid. So actually fractional distillation is the separation of the liquid on the basis of their boiling point. Okay, so that physical property is boiling point. So these liquids have their different boiling points. The one which has a less boiling point will be evaporated first, condensed and will be separated. Okay, the apparatus shown is used to compare the rates of the reaction of the different metals with hydrochloric acid. So we have over here hydrochloric acid, FeCl. Okay, we use for all of these metals. Okay, so small tubes to hold the metal sample. This is the metal sample and this is string. Okay, when we remove this car, so string is released and it falls, and in this way the metal sample reacts with hydrochloric acid. Okay, so what happens? Metal used is calcium and the mass in the gram is 0.080. Iron is 0.112, magnesium is 0.48, zinc is 0.13. Okay, Okay, so these are different masses of the metals which we are using. So what will happen? In fact, when this metal reacts with this hydrochloric acid, you know that metal plus acid, what it forms? Salt plus hydrogen. Okay, so salt is aqueous, no problem, it remains over here, but hydrogen which goes over here, okay, so it is measured. Okay, 50 sum of the measuring cylinder, in this cylinder hydrogen is measured. Okay, place a sample of this one of the metals in the small tube, transfer 50 cm cube and this much concentration of hydrochloric acid into the conical flask, places the three small tubes into the apparatus as shown in the diagram. Okay, places 50 cm cube of hydrochloric into the conical flask. Okay, sorry, places the small tube into the apparatus as shown. The small tube is placed. Okay, tips the flask so that the small tube falls over and the metal and the acid come into contact. Still start the time, and you have to start the time as well when they start reacting. Record the total volume of the gas, okay, formed at a regular interval until the reaction finishes. Okay, repeats the method with each metal. You have to repeat this method with each metal. Okay, by using the same volume and same concentration of hydrochloric acid and the same mass of the metal as well. Okay, so name the alternative piece of the apparatus that could be used instead of measuring the cylinder to collect the gas and measure its volume. Instead of using measuring cylinder, what we could have used? Gas syringe. Okay, you know that it is used to measure the volume of the gas. Measuring syringe or gas syringe. Okay, the gas collected in the measuring cylinder is hydrogen, of course. Okay, give the test and its result to show that this gas is hydrogen. Test is glowing splint is brought closed. Okay, to gas, glowing splint, and pop sound is produced. Okay, this pop sound show indicates this is the hydrogen gas. Another student thinks it would be easier to remove the bung. Bung means that cork. Okay, from the flask, add the metal directly to the acid and then replace the bung. Okay, means he wants to say that by removing this bung and then instead of adding, keeping the metal over here, he will add directly and then he can replace this with the then he can again put this bung over here. Okay, this is the bung. Okay. So state two disadvantages of this method compared to the first described. Actually, in this way the hydrogen is released first thing. Hydrogen is released. This is the one of the disadvantage. And the second is it may be inaccurate. Okay, means when hydrogen is released, so you cannot get the accurate result. You cannot measure the accurately the volume of hydrogen. Inaccurate measurement of H2 volume. So a graph representing the results as shown, you can have a look over here. This is the graph. Greater the gradient, greater the rate of reaction. This is the for A, so it means it has greater gradient, it has greater reaction. But the hydrogen produced is same. Okay, it's done over here. So give the correct label for the each axis of the graph. This we can say time. This is the time. And the next thing, what is over here is we can say on the, this is the on y-axis. Okay, sorry, this is x-axis, this is time, and here is the volume of hydrogen produced. Okay, actually constant volume is produced. Okay, state Y curve A starts steep, gradually level off and become horizontal. Yes, you will have to explain. In the start, when the initial concentration is high, sorry, here is the volume of hydrogen. State Y curve A starts steep. When it is in the initial state, it is steep. Gradually levels off, its level decreases, become horizontal. In the start, rate of reaction is very high. Is high due to high initial concentration. So high volume of hydrogen produced, which decreases with time and becomes constant and becomes means it shows when it becomes constant, so it means all the hydrogen which had to produce so has been produced. Okay, here it means when it becomes horizontal, showing reaction is ended. Identify which of the metal gives the each of the curve A, B, C and D. Which metals are there? A means actually A is showing that it has a higher rate of reaction. B has a bit lower. Greater the gradient, steeper the gradient, greater the rate of reaction. Okay, so gradient is decreasing, so it means the rate of reaction is also decreasing. But at the end, you will get that the equal volume is produced of the hydrogen. So we have different these metals. So which one is more reactive? The one which is more reactive will give the more amount of the hydrogen, will give the higher rate of the reaction. So you know that. Please send camels, monkeys, zebra in large heavy crates soon. Like this is the activity series. Okay, please send camels, monkeys, zebra in. So camel, this is the first camel. Okay, calcium, monkey, manganese, zebra, C, and iron, D. Means reactivity is decreasing. This is the reactivity series from most reactive to the least reactive. Okay, arrangement of the metals. Okay, once again. So here is the calcium, lizard, camel, monkeys, zebra in. Okay, large heavy crates. Different methods of each metal are used to in the four experiment. State 3 variable that must be kept constant at the constant for the experiment. So concentration of ICl, okay, it has to be kept constant. Volume of ICl, it has to be kept constant. Temperature during reaction, it also has to be kept constant. Okay, we cannot change. Just by different masses of the each metals are used for the four experiment. Masses are different, but they have the same number of moles. To have same number of moles of each metal, Okay.